Good morning students, welcome back to online class. Today we are going to discuss the second lesson, book inside problems. Let's see the first problem. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of an object? So what is given in the problem? Let us consider the smallest object. Okay. Now the object, it travels and it covers a particular distance, isn't it? So it covers the particular distance is given 16 meter. What is the time taken is given 4 seconds. And again the same object, it covers the same distance, that is 16 meter, but the time is not the same time, isn't it? It's not taken as a uniform motion, it undercomes in the non-uniform motion only. The time is not constant, isn't it? So the object it moves, it covers a distance of 16 meter, but it is taken, the time is 2 seconds. So we could able to find out what is the average speed of an object. So first we could able to find out what is the total distance covered by the object, and second we could able to find out what is the total time taken by an object, and finally we could able to find out what is the average speed of an object. Already we know the speed formula or in the average speed. Average speed is equal to total distance covered by an object to total time taken. That is only the average speed. So first we have to write what are the data are given, and first find out what is the total distance. The total distance covered or traveled by the object. So the total distance traveled by the object. So the first distance is given 16 meter and second distance is given 16 meter. So what will come? 16 plus 16 is equal to 32 meter. This is the total distance traveled by the object. So what about the total time taken? So the time total time taken by the object. First is covers the 16 meter distance, the time taken is 4 seconds, and after the same distance the time only varies, isn't it? 2 seconds. So what will come? 4 plus 2 is equal to 6 seconds. So what we have to find out? Average speed. So average speed is equal to total distance by, short we could write, total distance by total time. Now we have to substitute the values. What is total distance? 32 meter. What is total time? 6 seconds. We have to simplify. First we have to use the second table. So what will come? 3 2s are 6 and 16 2s are 32 is needed. And again is 16 is divided by 3. What will come? Say in the third table, 5 3s are 15 is needed. So 5 3s are 15, remaining 1, we have to put point, afterwards add 0, so it's 10. 10 is divided by 3, 3 3s are 9, again 1 will come, we have to add point and 0, so 5.33. What is the unit? Meter by second. So what is the average speed value? The average speed of an object is 5.33 meter by second. Are you understand now? First we have to find out the total distance. Second we have to find out the total time taken and substitute the average speed and total distance by total time. and you have to substitute the values and simplify. You will get the answer 5.33 meter by second. Now let us move on to the second problem. A sound is heard 5 seconds later than the lightning is seen in the sky on rainy days. Already you know that during the rainy times we could able to hear the sound first, is it? Afterwards only we could able to see the lightning, yes or no? And find the distance of location of the lightning, we could able to find out. Given the speed of the sound is given 346 meter second power minus 1. So first we got to substitute the values. What are the values are given? First you have to write speed of sound. Speed of sound is given 346 meter second power minus 1. It's a constant value is given in the problem. And what is the times second is given? Time is equal to 5 seconds later than the lightning is seen in the sky, isn't it? The light travels very faster. What is the velocity of light? 3 into 10 power 8 meter second power minus 1. So we could able to see the lightning first. Afterwards only we could able to hear the thunder sound. That is only is given in the problem, isn't it? So 5 minutes later only we could able to hear the sound. What is the distance of the location of the lightning? We could able to find out. So time is equal to 5 seconds. So what is the speed formula? Already we know. Speed is equal to a distance by time. Speed is equal to what formula? A distance by time. In this problem, we are going to find out what is the distance only. So time is cross multiplied here. We obtain one more formula. A distance is equal to speed into time. Now you have to substitute the known values. 346 and time is 5 seconds. So what will come? 346 is multiplied with 5. So 6 5s are 30. Is needed. Remaining 3. 4 5s are 20. 20 plus 3 23. Remaining 2. 5 3s are 15. 15 plus 2 is equal to what? 17. So 1730 meter distance. What is located here? We could able to find out the distance, that is the lightning distance. So distance equal to 1730 meter. Thus the distance of the location of the lightning is 1730 meter. Is given the problem. And time 5 seconds. First you write the speed formula, and using the speed formula only we have to write the distance. Distance equal to speed into time, and substitute the values and also the simplify, you will get the answer. Now let us move on to the third problem. The brakes applied to a car produce an acceleration of 6 meter second per minus 2 in the opposite direction of the motion. What is the meaning of the acceleration produced in the opposite direction? The car comes to stop, isn't it? If the car takes 2 seconds to stop after application of brakes, calculate the distance traveled during this time. So the brake is applied before the 2 seconds the car is in the motion only. And after that the brake is applied, it produces the negative acceleration. What is negative acceleration? The negative acceleration is called as deceleration, is needed. The deceleration is nothing but the acceleration is acted in the opposite direction. First we have to write what are the data are given in the problem. First is given acceleration, is needed. So acceleration, it is denoted by the symbol is A, already we know. Acceleration is equal to what value is given? 6 meter second power minus 2. But it is acted in which direction? Opposite directions. So what you have to write? Minus 6. A is equal to minus 6 meter second power minus 2. And after that time 2 seconds, that is t is equal to 2 seconds is given. The car comes for the stopping, is needed. So what is the final velocity? The final velocity, it is denoted by the symbol is V. V is equal to 0. Then what about the initial velocity? The initial velocity is not given, is needed. So first we have to find out what is the initial velocity, and after that we have to find out what is the distance traveled during this time. We could able to find out. Okay, what are the values we have to find out? Initial velocity and the distance traveled by the car during this time. So first we got to find out the initial velocity. From the equations of motion only we are going to find out the initial velocity value. From the first equation, from the equations of motion. What is the first equation? That is V is equal to U plus AT. V is equal to what formula? U plus AT. And after that we are going to substitute the values as V values already we know. The car comes for the stop. Is in the stopping only. So V is equal to 0. U only we are going to find out. So 0 is equal to U plus A. What's the value of A? Minus 6 into. What's the value of T? 2. So 0 is equal to U minus 6 into 2. So 6 2s are 12 plus into minus. So what will come? 0 is equal to U minus 12. Then minus 12 is comes this side. It gives us U is equal to 12 meter second power minus 1. This is the initial velocity of an object. So next what we have to find out? Total distance. So the second equation is equal to ut plus half into 8 square. Substitute the values as 12 into time be the 2 plus half into A value is minus 6 into T value is 2 seconds. It's needed 2 square. So what will come? 2 12s are 24 plus half into what will come? Minus 6 into 2 2s are 4 is needed. Now you have to simplify. 1 2 is 2. 2 2s are 4. So what will come? That is 24. Minus 6 into 2 is equal to minus 12. Plus into minus, that is 24 minus 12 is equal to 12 meter. So after the time the brake is applied, the car traveled the distance is 12 meter only. Are you understand, children? So first we got to substitute the formula V is equal to U plus AT. And second we got to substitute the formula S equal to UT plus half AT square, and we obtain S equal to 12 meter. So the car will move 12 meter before it starts after the application of brakes. I hope students you understand the 3 problems. Thank you, children.
Very good morning, my dear students. Today we will learn about Bohr's model of an atom. Last class we have learned Rutherford's atomic model. In this class we learn about Bohr's model of an atom. In 1913, Niels Bohr explained the causes of the stability of the atom in a different manner. Because we know Rutherford's model could not explain the stability of the atom. So Niels Bohr tried to find the stability of the atom. Let us see the main postulates of Bohr's model. What is the meaning of postulates? Accepted points are called postulates. So now we see the important postulates of Bohr's atomic model. The first postulate is, in atoms, the electron revolve around the nucleus in stationary circular paths called orbits or shells or energy levels. Students, you know, in Rutherford's model, electrons revolve around the nucleus in closed circular paths, but in Bohr's model, electrons revolve around the nucleus in stationary circular paths called orbits. While revolving around the nucleus in an orbit, an electron neither loses nor gains energy. So, when the electrons revolving around the nucleus, that time it will not lose or gain energy. But an electron in a shell can move to a higher or lower energy shell by absorbing or releasing a fixed amount of energy. An electron moves from the lower energy level to the higher energy level, that means lower orbit to the higher orbit, it absorbing a fixed amount of energy. So lower to higher orbit, it absorbing energy. An electron jump from the higher energy level to the lower energy level. It releasing a fixed amount of energy. The orbits or shells are represented by the letters capital K, L, M and N, or the numbers 1, 2, 3, 4. The orbit closest to the nucleus is the K shell. It has the least amount of energy. So, Bohr called them as energy level or energy shells. So, first orbit name is K, second orbit L, third orbit M and fourth orbit N. So, students, I hope you understood that important postulates of Bohr's atomic model. One time I repeat. In Bohr's model, according to Bohr's model, in atoms, the electron revolve around the nucleus in stationary circular paths called orbits or shells or energy levels. While revolving around the nucleus in an orbit, an electron neither loses nor gains energy. An electron in a shell can move to a higher or lower energy shell by absorbing or releasing a fixed amount of energy. The orbits or shells are represented by the letters capital K, L, M and N, or the numbers 1, 2, 3, 4. So, these are the important postulates of Bohr's atomic model. And students, one main limitation was that this model was applicable only to hydrogen and hydrogen-like ions. For example, helium, lithium and beryllium ions. It could not be extended to multiple electron nucleus. So, this is the main drawback for this Bohr's atomic model. So, children, I hope you understood the postulates of Bohr's atomic model and the limitation of Bohr's atomic model. Students, we know electrons revolving around a nucleus in a circular path is called orbit. And how many electrons fit in each orbit? We can use 2n square formula to find the maximum number of electrons in each orbit. N denotes the number of the orbit. According to 2n square formula, K shell, N indicates that is a number of orbit. So, we know first shell is K shell. So, in K shell, N is equal to 1 because that is the first shell. So, first shell, so instead of N, we substitute 1. So, 2 into 1 square is equal to 2. So, in K shell, maximum number of electron is 2. And next, second shell L. So, instead of N, you substitute 2. So, 2 into 2 square is equal to 2 into 4 is equal to 8. So, in L shell, there are maximum 8 electrons are present. Like M shell, maximum number of electron 18 and N shell, maximum number of electrons 32. So, we have to find the maximum number of electrons by using this 2n square formula. So, students, how many electrons maximum present in K shell? 2. L shell 8. M shell 18. N shell 32. Okay, students. So, today we discussed Bohr's atomic model and limitation of Bohr's atomic model and the 2n square formula. Next class, we will discuss electronic configuration of atoms. Thank you.